Hi folks, I have another lesson for you about how to calculate enthalpy change from heat of formation. So in the previous lesson we looked at bond energies and how to use that to calculate the enthalpy change for a reaction. In this case we are going to be using the heat of formation. Heat of formation essentially means the amount of energy required to make this substance from its elements in their standard states. And the key thing, the benefit of this is if an element is already in the standard state in the chemical equation, then the heat of formation is zero because the amount of energy required to make that substance in its standard state from its standard state is 0 kilojoules per mole. All right, so that's a key thing to remember, and we will be using that information in the question below. So over here we have again C3H8, which is propane, and we are burning it in oxygen to form CO2 and H2O, and we have a balanced chemical equation. All right, so to calculate the change in enthalpy delta H for this equation, we have to find out the enthalpy heats of formation for each of these substances, the amount of energy required to make each of these substances from the elements in their standard states. So C3H8, and again this we will be able to find in the chart above. C3H8 is negative 104, so that's a negative 104 kilojoules of energy right there. And now for oxygen, and if you look for the oxygen, it is not on the chart. The reason that is element oxygen is in its standard state, and therefore the amount of energy is 0 kilojoules of energy that is required. So 5 times 0, which is a 0 essentially, which is 0 kilojoules. And CO2, I'm just writing the information below, is negative 393.5. So this is 3 times negative 393.5 kilojoules of energy, which results in a total value of, and again I'm going to use my calculator, 3 times negative 393.5, and that gives us a value of negative 1180.5 kilojoules of energy. Now, next we have water, which is H2O, and since this is a combustion reaction, I know this water is going to be in a gaseous form because of the amount of heat that is going to be released in this reaction because we are burning a substance. So, water in the gaseous form has a different amount of energy than water in a liquid form, and so in this case, I'm going to be using the water in the gas form, and therefore here I will have 4 times negative 241.8 kilojoules of energy. And therefore, to calculate that value, now I will use the calculator. 4 times negative 241.8 kilojoules of energy will give me a negative 967.2 kilojoules. So that is the total amount of energy that is the heat of formation for H2O, for 4 moles of H2O. Now, once we have the heats of formation for all of our substances in our balanced chemical equation, what we can do is we can find delta H by taking the sum of all the energies of the products, so H of the products, minus all the sum of the H's of the reactants. And so the products in this case are negative 1180.5 kilojoules of energy plus negative 967.2 kilojoules of energy, and then we are going to subtract the negative 104 kilojoules of energy plus 0 kilojoules of energy. And when we calculate that, again, we're going to use our calculator, put all the information into the calculator, which is negative 1180.5 minus 967.2 minus bracket negative 104 bracket close, and we get a value of negative 2043.7 kilojoules of energy. Right, all our values were, well, the least specific value or least significant figure value was 104 or 0.0, and therefore 0 decimal places, so the answer rounding off, is negative 2044 kilojoules of energy. So based on this reaction, this information, we can provide a delta H value for this reaction as a negative 2044 kilojoules of energy. Also, a point to realize is that this value is not exactly the same as the bond energy value, and as we said, the reason for that is the bond energy values are not very accurate, um, and they will be close, but they will not be the exact values, and that is okay. As long as you're showing the procedure and you are showing using the correct substances, you should be getting an answer which is very close to the true accurate answer. I hope this lesson was useful in understanding the process of how to calculate the enthalpy change from heat of formations.